Hello everyone, welcome to this new video again. In this video I will be going to explain that how you can connect to the cloud from your Arduino device. For Arduino device I will be using your ESP32, but the same code you can write with the Arduino Uno also, and also with ESP8266. So the code will work on all the devices. So to send the data to cloud, there are multiple platforms there for the cloud communication. So one thing I am going to use today is ThingSpeak website. So it's a product of MATLAB, and also you can use Arduino Cloud, Arduino IoT Cloud. You can use Amazon Web Service also. So I'll try to cover all the things in my next videos. So in this video I'll be explaining that how you can send your data. So that is your sensor data or any data from your Arduino devices to the cloud. So for that you need to go to this website. I will post the website link in the video description, and there you just have to log in there. If you don't have an account, then you can just create an account there, and it's a free account actually. You can use that account, so there is no problem. You don't have to pay anything, but some limitations are there with free account. So first I will tell that how you can create a channel there and how to use that. Then we'll go to the Arduino code. So you can see here there are some channels I have already created. But once you open this, you will just find this new channel here, and click on this new channel. So once you click on this new channel, so then you will get it here what channel name you want to give. So let's say I will give here ESP32. So I am writing code for ESP32, and I am going to use the gas sensor for sending the sensor data. So I will write here ESP32 gas sensor. So it's user depend, whatever you want you can give. Then description is there. If you want, you can add some description, but right now I'm not adding any kind of description here. And this field 1, field 2, field 3 is what? So basically these are the fields, or these are the variables in which the sensor data is going to be received. Okay, so this field name I can give here. So I will write gas sensor or gas level I can write. So gas level, it will show me the gas level, because I am using one sensor for today's video. So I am just going to select one variable here, that is field 1. So remember, field 1 is a variable that will be used by the program, and gas level is the name that will be used for displaying that. Then there is field 2, field 3 and there. So if you have multiple sensors and more data you want to send, then you can use all these things. After that, whatever is there, leave it by default, and then you can just click on save channel. So once you click on this save channel, so it will just save the channel, and it will open a private window for you. So this is the private window. So see, it is a private view is written here, and then this by default one graph will come here. What is this graph? One, see, the variable I have created is written as gas label, and date is there. So basically date is there, but it will come as time. So whatever data comes to the channel, so it will be getting updated over the time, and that you can see here. And there are some other settings also you can do here, that also at the towards the end of the video, once program or once data comes to this website. Next is public view. So basically this is the view if you give this channel ID or this particular link. So you see here this particular link on the browser. So if you give this link to anyone, then they can view your data. So basically you can make a weather forecast website, and if you just make it public, then everyone can see the weather forecast if you are using a temperature sensor, humidity sensor and all. And to that you have to switch on to the sharing option. So that is here. Okay, next is channel settings. So channel setting is nothing but that while creating this page came. So this is the channel setting. If you want to add more variables, then you can. And using one variable, it's fine. Using second variable, more than one variable, then you need something called channel ID. So this is the channel ID. This is also view here. You can see this here also, it is available. And then sharing, as I told you, in sharing you can just switch on the sharing. So three options are there. So if you make it share channel view with everyone, then everyone can see the data that you post. And the next important thing is this API keys. So this is the factor, I'll say that this is the address of this particular channel that you have created, where the data is going to come. So see here, two API keys are there. One is write API key, one is read API key. So remember that whenever you are going to send some data from your Arduino or from ESP32 to the website, from Arduino to website, then you are going to use this write API key, or if you are going to do the reverse process, then you are going to use the read API key. So we'll be using this API key, and or else we can one link is given here, we can use this link as well. So now this much from the channel settings, so quick and so easy. So you can just create a channel and you can get the API keys, and now we'll go to the programming part. I'll just open a new Arduino file and I'll try to write the program one by one. So this is the new Arduino environment here. So you can see void setup is there, void loop is there. So to use this particular ESP32, so what I need to send the data, first of all I need two library files here. So I'll explain why these library files are required. So one is your as include wifi.h. okay, so this is the library file that is required for the ESP32. so that to connect, I'll just make the size bigger little bit so that you can view. Okay, so this is the library file that is required for the ESP32 to connect to the Wi-Fi. Now if you are using Arduino board, then this is not this library file you have to take, but in Arduino you know there is no there is no Wi-Fi inbuilt, so you can use ESP8266 as well with that, or else you can use the ESP32 directly. So it's better if you use ESP32 because in one board you can do the things. Next library we have to include that is your next library is your HTTP client. So remember, however I am writing, have to write in the same way, so it's case sensitive. Okay, so HTTP client is, it will be used as a client server socket communication. So I have told what is socket communication and what is client server communication, so you can see my previous video on that. So basically it will be used to communicate with the internet. Okay, now we are going to declare one variable that is int x equals to 0. So why I am declaring this variable? Basically we will be using the same variable to read the data from the sensor, and then we'll send this variable x to the cloud. So okay, now next what we have to do? So next we have to next you have to set our Wi-Fi. So once you set your Wi-Fi, then only the ESP32 module can get connected to your Wi-Fi device, or whatever hotspot created from mobile or modem you are using. So for that purpose you need to give the Wi-Fi credentials here. So what is that? So I'll write constant, so const, and a variable name is character, and it's a fixed variable, and SSID is the variable name I am giving. So you can use anything, hotspot name or anything. Okay, that is equals to, so I'll write in the character my hotspot name I have given as Sambhu, my name, and we have to give one more same thing. So what is that same thing? The password. Okay, so I'll write here password. You can use your own writing. I am just writing for password for understanding. 1 2 3 4 5 6 7 8, let it be my password. Okay, so this is the hotspot data I have given. Next is we have to define that to which website we are going to send our data, right? So we are going to send the data, where to send the data. Okay, what to send the data? So for that I will declare one string variable here, and I will name that as server name. Okay, so to this server name I am going to send my data. Okay, so what is this server name now? How to write that? What to write? So for that you have to go to the website that you have created. So here you can see the link is there. So you just copy this link from here and paste it over here within code, as it is a string we have declared. So see, this is the address where we are going to send our data. Okay, so what is this address? I will just tell So you see this is the address, and you can see one API key is written inside this address. So this API key is nothing but this write API key is written here. Okay, this is the address I am taking. So to this address I am going to send my data. So now for setting up the Wi-Fi, we need to do initiate some more variables. You can skip that also, but for better understanding and working, I usually use it. So I'll write unsigned long character. So here also I need to give the semicolon. I forgot that. Okay. Then one more. So basically I am just writing this so that we can connect to the Wi-Fi if Wi-Fi doesn't get connected in time, so that we can get a message that Wi-Fi could not be connected, or else we will be waiting for like infinite time. So what is this 60,000? Basically 60,000 means I am going to wait for 60 seconds, that is 1 minute. Okay. So this much is required before we go to the void setup. This much things we have to give. Next, in the void setup, so we need to write our code and what setup we are going to do. First of all, I'll write pin mode. So pin mode. So I can use any pin from the ESP32. So let's just write 34. I'm just using it like this. It's not mandatory that you need to take 34, and the type is input. So here in 34 number pin we are going to take the input. So you can refer to my gas sensor video where I have explained how you can take data from gas sensor. So I'm not explaining that now. So then I will write serial dot begin. So we need to display whatever is happening inside the ESP32. So that I will write. So this will be displayed in serial monitor, and then Wi-Fi dot begin. So we have to start the Wi-Fi connection as well. So the syntax is like this. So once you're writing, you make sure that the colors are coming perfect, so that you know that your code is correct. Okay. So Wi-Fi dot begin. So now I will give here SSID and password. Okay. So that the same thing I have declared here I am writing. So now it will try to connect to the Wi-Fi. Okay. Then I will just print once the serial dot println. So I will print a message connecting. So I usually prefer to print all those things because it will get me to know that what exactly is happening inside the ESP32. So I'll let print. Then we'll be waiting for connect. Okay. So here I'll write wait for connect, so that I'm just going to while loop. So while, so Wi-Fi dot status. So what is this? Basically Wi-Fi dot status will tell that if it is connected or not. So if Wi-Fi status is not equals to, okay, capital W underscore connected. So this is the inbuilt function for Wi-Fi. So if it is connected, the status is Wi-Fi connected or wireless LAN connected. If it is not connected, then this loop I am writing. So if it is not connected, then what will happen? So if it is not connected, we will wait for a delay of 500 millisecond. Sorry, delay of 500 millisecond, and then we'll print serial dot println, not ln, only print a simple character. I will print dot space dot. Okay. So like this till the Wi-Fi is not connected, it will keep on printing these dots. Okay. So if you have seen, the dot are like buffering, something like that. Okay. Next what we'll do, we'll just serial dot. So serial dot println, new line, will just print. So first I am giving a blank space, so it will go to a new line. Okay. And then we'll just again print connect to Wi-Fi network with IP address. So what is the IP address? I can print here. So for that I will write again serial dot print. I am not using println, I want to print that in the same line. So I will write Wi-Fi dot local IP. So basically this local IP is a inbuilt function which will give me what is the IP address it has got connected. Okay. So now this void setup is completed. I think this is one extra came. Okay. So this while loop started here, ended here. Okay. So this is fine. Now in the void loop, so we are going to write our code to read the data and to send the data. So as I told, first we will see that if in bracket I will write millis is a inbuilt function. So if millisecond minus last time, so last time what I have declared 60,000 is greater than timer delay, then if I think I missed one bracket here, again, then if Wi-Fi dot status is Wi-Fi status is equals to YWL underscore connected. So then what will happen? We will go to another if loop. So if it is connected, then simply x equals to analog read pin number 34 that we have taken. Okay. So it will now read the data and then it will send the X data. So I am just creating a function here, send data, and will be declaring that function later. So I will end the brackets, one bracket, this bracket, and the void loop bracket. Okay. So all the brackets are end now. Next, what we are going to do? Okay. So this if is closed. Now here I will write else. So what will happen if it cannot send if Wi-Fi is not connected? So it will just print for me serial dot println. So if Wi-Fi is not connected, I need to know that. So for that I will just write Wi-Fi not connected. So if your mobile gets switched off, it cannot be connected, then it will do that. Okay. So now after this I will write after this loop. So last time is equals to millisecond. So I will just update the milliseconds. So millisecond will get updated one by one. Okay. So are the brackets correct? Let me just see if the brackets are correct or not. Okay. So else, this bracket is for if, this bracket for else. Okay. Then last time for this one, and then this one, then this one. Okay. So many brackets created on its own. This one ends here and this one ends here. Okay, fine. So now we are done with the void loop. So then what we are going to do? We are going to declare the function that I have taken. Which function? The send data function. So we can use the send data function whatever I am going to write inside there also, but I prefer to write it here externally. Send data. Okay. and in the same data I'll just declare one variable, means the function is going to reply one variable for me, and that variable will be assigned to this x. Okay, that's how it works. It's just a C loop, C concept, so I am not going to explain the C concept. So here what we are going to do, first of all I am going to take on initialize an object, so HTTP client. So I am declared one object for HTTP connection, and then serial dot println data. So this x variable is now assigned to data. I'm just printing it here inside this loop. So we need to know what data is going to be sent. Okay. So next is I'll declare one more variable, string URL is equals to server name. So what is the server name? So server name, you see we have server name we have created here. Okay, so this one I am taking there. So I am basically I am declaring there one more string variable, and I am making that some changes. I will explain what. So that is equals to server name plus field 1 equals to plus data. Okay, so what is happening here? So you see here in the server name, you can see in the server name this field 1 is equals to 0. Okay, so I am making what I am making here, and field 1. So see here, and field 1 plus data. So I am just adding that to the string. So instead of 0, now this 0 will be replaced with this value, this data value. Okay, so next we have to start the connection. So for that I need to write http.begin, and the inbuilt function for that is url.c _str. Okay, so this is the inbuilt function. So URL is what? URL is this URL. Now this URL contains the website ID and the API key .c _str. Okay, this is the syntax for beginning the serial connection. Next what we have to do, so once it has started sending the data, so we need to do one more thing. We need to know that successful data sending is happened or not. So for that I need to know what is the response code. So every time any data is sent between two client and server in internet, so there is always a HTTP response code is generated. So I need to know that value. So I'll write here int one integer variable. So that variable name is HTTP you can make the variable smaller. So for understanding purpose I am writing it full. HTTP response code is equals to HTTP dot get. So this is a function that is used to get the response code after the data is sent. Okay, now if I write a condition if loop, we need to know that whether the data is perfectly sent or not. So if this response code, I'll just copy it. If this response code is greater than 0, so response code can be anything, so many response codes are there, but I'll say if the response code is greater than 0, then I'll basically you need to get the response code as 200. If you get something else other than 200, then the data will actually not be sent. Okay, so if the HTTP code is greater than this, then serial will just print the response code. So see, whatever I am writing here, I am just want to know that what is happening inside that. So response code is response code is, then again serial dot print the response code is what? HTTP response code. Now it will print what is the response code. I will end the loop here, and else what will happen? Else, so I will just copy these two again, and here I'll see. Okay, else what is, if it is not greater than 0 or it is not 200, then that's a error. So I'll write here error code. So if data is not sent, then it will print that error has happened and it will print the error code. So after HTTP we have begin here. Okay, so HTTP begin happens, so again we have to close the HTTP also. So for that I need to write end. Okay, so now the code is ready. So step by step I have explained all the line. Let us now connect our ESP32 and let's try to upload this code, and we'll see that whether this code is working or not. I hope it will work. Let me just open my camera for you, then I'll continue. Okay, now you can see this is the ESP32 I am going to use. Okay, I will connect this to the system now. Now it's power off. Okay, so once that is powered off, I'll try to upload the code now. So okay, I have to save the code first, so I'll save it here. Okay, you can just see the code from the video. You can pause the video and take the code, but if you want that code, then just put a comment. I'll send you the code over the mail, or I'll paste it there. So I'll write ESP32 gas. I've saved the code, and now it is compiling the code. So this is the gas sensor I am going to use. In the meantime, I can see. So you can see that it is getting compiled. Okay, so see here it is getting compiled now. So it takes a bit time to compile, so I'll just pause it till the compilation ends. It doesn't take more than 2 minutes, but I'll just. Okay, so there is a error came here. That's because I have not given semicolons here. I forgot that. Okay, now again I'll do that. So it's compiling again. So in the meantime, let me just tell the pin of this gas sensor. So once you have the gas sensor, behind it will be written all the pin numbers. I don't know whether it will be visible or not. Okay, so see here. So here it is written VCC, then ground, then D0 and A0. So remember, we need to use the VCC. Okay. Okay, what happened to while? Okay, so while connected, one more bracket I have missed here. Okay, I hope this time there will be no error. So again it will come error because I have forgot the semicolon here also. So that semicolon should be here. Yeah. So this is the problem if you don't see the syntaxes and all every time. I hope I have not missed anywhere else. I don't think so. Okay, I think everything else is fine. So one more error is there. So what is that? Okay, here semicolon missing. Okay, so now I think everything else is fine. So it should be done now. So I think it is going to be compiled soon. So there are some more semicolon errors, so I just removed that. So see, it is connecting to port, so I'll just press this boot button once and remove it, so it will be connected now. So now it is uploading the data. In the meantime, when the data is getting uploaded, so let me connect this gas sensor. So for this gas sensor, this white one is connected to VCC, black one is the ground. So I'll connect, so you can see here. So here I am going to connect the VCC, and here I am going to connect the ground. Okay. So white one is the VCC, I will connect just like this. So see, now it's ready. And pin number, each one is will be connected to pin number 32, 34 that I have taken. So 34 is 1, 2, 3, 4 from here. So 1, 2, 3, 4. Okay. Now my gas sensor is connected. Okay, so okay, this is ready. Now let me just open the serial monitor, and I will press once the reset button in the ESP32, so that we can see what exactly happening there. So, okay, now it is printing connecting. Now it is connected to my Wi-Fi address. Okay, so now we'll see if the response code comes as 200, we'll go to the ThingSpeak then, and we'll see whether the data is uploaded or not. So this is my ThingSpeak. Okay, so data should come here. Okay, so once this response code comes, we'll see that data will also be available. So generally ThingSpeak takes some time, around 15 to 30 seconds to get updated. That's why I don't prefer ThingSpeak, but I will prefer Arduino IoT Cloud, which sends in data in seconds. Okay, so let's just wait for some time. The data should be updated. I'll just check. If there is no error in the code, then the data should get updated. So data is 3596 and the response code is 200. So you should be getting that here now. If response code is 200 means you should get the data here. So now you see you get the data here. You can see the time and the date also, and this is a GMT. So it sometimes it might not be exactly same as your time. You have to set the time zone also. So here see 21:45, this is the current time now. Here you can see this is the current time, so it gets updated. So now it will, if I wait for some more time, it will send one more data. Let's just wait for some more time. Basically this ThingSpeak channel is slow, what I have experienced. Next video I'll try to explain the Arduino IoT Cloud, which is better and faster. So you see second data is there, 3549 from the sensor, and it should get updated here. You can see this data is here. Okay, now something more I will tell in this ThingSpeak what you can do. So here you can add some more visualization, add widgets also. So if I add one widget here, you can see gauge is there, numeric display is written, lamp indicator is written. So if I select this numeric display, then I will just click here and I will create the numeric display. So see here by default the update interval is 15 seconds, so it's quite high. Okay, I'll create this. Now you can get the numeric display here. So whatever the latest data is available, that will be shown here. Okay, now this video is not required. Actually I'll keep it here on the top, it's not required, and I'll just go to the serial monitor now. Yeah, so next data is, see your 3474, so it should be updated here. So it's just showing now the previous data, that is 3549, Now the data is updated to 3474. Okay, so like this you can make your own project and you can send your sensor data to the cloud using ThingSpeak. So with this I will just end this video, and if you want to know the code, then just put a comment, I will paste the code there. Okay, and the how to use the gas sensor and explanation of that you can find in the description. There is a separate video on that, so do watch that, and visit the channel again for to get the update on the Arduino IoT Cloud. So I'll explain that how you can use that platform, and I'll say that that is more easy and convenient compared to ThingSpeak. So thank you, have a good day, good night.